now let's simulate the signal conditioning circuit for the MQ-7 gas sensor. Initially, let me choose the 5-terminal op-amp and then connect the voltage source to the 2-terminal . So this is one terminal. Let's connect the supply voltage to the other terminal. And then connect the ground. So we have seen that we have given the feedback resistors, like we had designed the ratio of the resistors. Let's connect them accordingly. So let's have my R1 resistor in the feedback loop. And then we had the R2 resistor . And we had given a constant 1.4 volt DC source to the resistor. So this was the 1.4 volts, which was our requirement. That is, when the function generator input goes to 0, ideally I should have a 1.4 volt constant voltage. Okay, now that we have this part, and then we have the other part where we take the input from your function generator. And here comes your input source from your function generator. So I choose the clock voltage source here, and this goes as input, and then connecting the ground to the source voltage. So here I have a constant 5 volt here, and now based on our discussion, let's give the values to each of the feedback resistors. So here 3.3K, and then this was 4.6 kilo ohm. So we need to monitor the output voltage. So here goes my probe at the output end. Now let's see what happens when we run the circuit. This is your negative. As you can see, it is inverted, -5, and you are getting -1.4. So this is your inverted output. Going back to my schematic here, you can see when your input is 0, the output remains at 1.4 volt, that is minus here, minus 1.4 volt. And then here again, ideally, if you observe, what you can see here from this is you can adjust the duty cycle. So I am adjusting this to 40% because based on our gas sensor specification, which said 60%, 60 and 90. So based on that, you calculate your duty cycle. The on and off period is very specific to the type of sensor what you are working. And if you see here, it can only give you the higher voltage, that is the upper voltage. Your source cannot give a different level in voltage, that is either 0 to 5 volts. That is why you can see why this kind of circuit becomes important, having a reference voltage, so that you can manipulate your output between two levels of voltage rather than just going it from 0 to 5 volts. So here I have set the duty cycle and we have given the input voltage. This is the on and off time. Now what do we do in order to get the positive voltage? Like I had mentioned, just give the feedback, that is the output of this will again be fed back to the similar circuit, and that is when you will be able to get the desired output voltage. Okay, let's give the output of this to the same circuit. Now I leave that to you. On the similar basis, connect the output voltage to the similar circuit. So you could work on the circuit what I had mentioned, and you could also refer to the presentation here and then observe if you are able to get the desired voltage level. So this was the basic simulation about how you can choose the different source, the input source voltage, like your function generator, it plays the role of your function generator, and how you can rig up the circuit using the multisim even before you get into the hardware. Now go ahead and give the output of this to the feed the output of this to the similar circuit, so that in your graph you observe the desired voltage, that is from positive 1.4 to 5 volts. So this is how you can generate signals of desired voltage level based on the requirement of your sensor or depending on different applications. This was about the simulation for the signal conditioning circuit for an MQ-7 gas sensor. Thank you.